Creating a website in itself gives a great feeling, and it just gets better when you're doing it using Angular. Hey everyone, welcome back to a whole new exciting session from Edureka. My name is Vajiha, and in this Angular tutorial, you will learn all that you need to know about Angular 8 and also to create your own Angular application from scratch. So our discussion will start with the basic stuff like types of web applications, AngularJS and its drawbacks, the rise of Angular and the differences between Angular and AngularJS. Then, we shall see who uses Angular and why is it so popular. Following that, we shall see what is new in Angular 8, and then I will show you guys how to install Visual Studio Code and Angular on your systems. Then, we shall be creating a project in Angular and see what are the files and folders that are created along with that project. Also, we shall see how this Angular application actually works. Before we move on towards the details of creating an Angular application, you must first know TypeScript. So for that, we shall take a deep look at TypeScript and the building blocks of Angular. After that is done, we shall move on to the most exciting part, that is creating a website from scratch. So before we begin, just make sure you subscribe to our channel and hit the bell icon to stay updated with all the latest Edureka videos. Also, if you're interested in getting an online training certification in Angular, check out the link given in the description box below. So coming back towards this session, let us first see what is web development. Web development is nothing but the development of applications or websites. Professionals who create web applications are known as web developers. These professionals use various methodologies such as Agile to create websites. The applications that were created earlier followed the traditional web applications model. Today, web applications are mostly single-page applications that are compatible both with desktops and mobiles. So what exactly is a traditional web application? If you remember, in the olden days, whenever you would request a web page from a browser, the page would reload for each and every request. These are nothing but traditional web applications. The main problem of this model was the page rendering process, which would happen for each and every request. This was very much time-consuming and it eventually disrupted the user experience. To overcome these issues, single-page application model was introduced in late 2002. The single-page model resolved this frequent reloading issue of web pages, making it much responsive and saving time. So what exactly is a single-page application? In a single-page application model, the website has dynamic interaction with the user. It rewrites the current page rather than reloading the page entirely. This leads to an uninterrupted user experience. Single-page applications will either load all the necessary code like HTML, CSS, or JavaScript, or just the appropriate resources are loaded and then added to the page if required. Neither is the page reloaded completely, nor will the control be transferred to any other page. There are many frameworks that allow you to create single-page applications. Some of them are Angular, React, Vue, Knockout, etc. However, the most widely used framework is Angular. Angular is actually the successor of AngularJS. So before we move on to see what exactly is Angular, let's take a look at AngularJS. AngularJS is an open-source front-end JavaScript framework for creating single-page web applications. It was developed by Google in 2002. There is no doubt that AngularJS was very popular in its time, but AngularJS actually lacked many important features that were being offered by other JavaScript frameworks in the market. AngularJS had a large bundle size, it had performance issues, and it did not support mobile devices. Therefore, to resolve these issues, Angular was created. Since then, Angular has taken over AngularJS, but the Angular community has said that they have extended the support for AngularJS applications until the 30th of June 2021. The rise of Angular. Angular is an open-source web application that is maintained by Google. It is based on TypeScript language, which is also an open-source programming language developed by Microsoft. TypeScript is basically the superset of JavaScript. With TypeScript, Angular introduced an object-oriented programming paradigm into web development. We shall take a deep look at TypeScript, but for now, let us differentiate between AngularJS and Angular. Angular was a complete rewrite of AngularJS. The architecture of an Angular application is different from AngularJS. The main building blocks of Angular are modules, components, templates, metadata, data binding, directives, services, and dependency injection. We'll be taking a look at each of these in a while. Angular does not have the concept of scope or controllers. Instead, It makes use of a hierarchy of components as its main architectural concept. Angular has a simple expression for syntax, focusing on square brackets for property binding and regular parentheses for event binding. Mobile development. Desktop development is much easier when mobile performance issues are handled first. Thus, Angular first handles mobile development. Modularity. Angular follows modularity. Similar functionalities are kept together in same modules. This gives Angular a lighter and a faster core. With TypeScript, Angular has instilled class-based object-oriented programming and static typing into website creation. So who uses Angular and why is it so popular? Angular is widely used by many companies to create their websites. Some of them are Google, Microsoft, Samsung, VMware, Santander, etc. Now there are many reasons why Angular is considered to be the best. Angular is easy to use. Angular allows its users to create full-fledged professional websites with much lesser code when compared to its rivals. The MVC architecture. Angular framework is based on the MVC or the Model View Controller architecture, where the models serve as the base and contain all the data, whereas the views basically deal with what the user sees. Compatibility. Angular works on the client side, which makes it compatible for both desktops and mobile applications. It provides filters. Angular provides filters to filter out different types of data such as numbers, lowercase and uppercase letters, etc. Not just that, you can also design your own filters according to your requirements. Two-way data binding. Angular allows two-way data binding, which means if any changes are made to the models, the corresponding views also get updated accordingly. Not just that, you can also update the models through the views. Now to show you all what this actually is, let me get back to my project. And over here, I'll just click on any of these courses. So as you can see, the name of my course is Python. Now two-way data binding actually refers to changing models from the views and views from the models. So as you can see over here, when I start deleting any of these letters, the name of the course is also getting altered. This is nothing but two-way data binding. We'll get into more details of this later on in this session. Modularity. This is one of the biggest reasons for Angular's popularity. Developers can make use of different modules to create single-page applications. Testing abilities. Angular provides easy and simple testing as a result of module separation feature. Angular is flexible and extensible. Angular is very accommodating when it comes to integrating with the existing technology stack. So what is new in Angular 8? Angular 8 requires the support of TypeScript 3.4 for web development. Opt-in Ivy preview. Ivy is the name given to Angular's next-generation compilation and rendering pipeline. This will help you optionally preview your website to see how it works. Differential loading. As a part of its build process, Angular 8 CLI will be able to produce both legacy and modern JavaScript bundles, that is ES5 or ECMAScript 5 or ES 2015 plus. ES 2015 is nothing but ECMAScript 6. This implies a differentially loaded client side with improved speed and TTI, which is time to interactive for present browsers. Backward compatibility of router. Backward compatibility of router helps in simplifying the upgrade path for large projects. Opt-in usage sharing. With this feature, the Angular team will be able to collect anonymous information with your consent to keep a track of the commands that are used and the time taken to build your projects. Dependency updates. Angular 8 has updated the dependencies on tools like RxJS, Node, and TypeScript. Now this is actually done for better performance and sync with the current environment. Web worker bundling. Web workers allow you to write code that runs separately from the main thread. This improves speed by parallelizing multiple tasks. The developers of Angular 8 have added bundling support for web workers as a result of requests from various developers. So now let's move on and take a look at the Angular architecture. Using Angular, you can build client-side applications in HTML and TypeScript. Now this is the reason why Angular can implement core and optional functionality of TypeScript from its libraries that you import in your application. The most basic building blocks of Angular are nothing but ng modules. Ng modules basically provide a compilation context for components present in your project. Ng modules will collect all the related code into functional sets. Therefore, it can be claimed that an Angular app is defined by a set of ng modules. Every Angular application will have at least one module, which is the root module. This module enables the bootstrapping process, which I will discuss later on, and typically has many more feature modules. The Angular components actually define views. Views are nothing but sets of screen elements that Angular can select among and modify according to your application's logic and the information that is given. Components in turn make use of services. These services provide application-specific functionality that is related directly to views. Service providers can be injected into components as dependencies, making your code modular, reusable, and efficient. Components and services are nothing but classes, having decorators that are used to mark their type and provide metadata informing Angular how to use them. The metadata for a component class associates it with the template that defines a view. Templates combine ordinary HTML with Angular directives and binding markup that allows Angular to modify the HTML before rendering it to display. The metadata for a service class tells Angular to make it available for other components through dependency injection. Components define many views arranged in a hierarchical order. The router service can be used to define navigation paths among various views of your application, as routers provide sophisticated in-browser navigational capabilities. So moving on in this session, let me show you guys how to install Visual Studio Code. The reason why I'm using Visual Studio Code is because it's lightweight, fast, and open source cross-platform application, and it also has other cool features. To install Visual Studio Code, you can go to the official website and download the version that is suitable for your operating system. Let me just go to the browser. Over here, I'll just type in VS Code, download. So as you can see, this is the official Visual Studio Code downloading website. From here, you can choose any of the versions that are suitable for your operating system and download the installer. Once you're done with installing it on your systems, all you have to do is just complete the setup and it will be ready to use. Since it's already installed on my system, I'm not going to download the installer again. So once you're done installing Visual Studio Code, you'll have to install Angular. The first step is to install Node.js. The reason for installing Node.js is that all web browsers such as Chrome, Firefox, etc. understand only JavaScript. Now all the code that we write in TypeScript must be transpiled to JavaScript. The TypeScript transpiler requires Node.js for generating the TypeScript code to JavaScript. So to install Node.js, you can go to the official website. And from here, choose the version that is suitable for your operating system and download the same. Once the installer has been downloaded, install Node.js on your systems. After you're done with the installation, all you have to do is open up the command prompt. And over here, just type in the command node-v. So as you can see over here, the version of Node that I'm using currently is 12.14.1. So the moment Node is installed on your systems, you'll be able to see the version of it. So I hope you guys are clear till here. The next step is installing the Angular CLI or command line interface. Here, I'll be making use of npm as a package manager which comes along with Node.js by default. Now to install the Angular CLI, all I have to do is type in npm install -g @angular/CLI. The -g over here specifies that I want to install the Angular CLI globally. This is going to take a while. The Angular CLI is actually a command line interface tool that is used to initialize, develop, and maintain Angular applications. We can make use of this tool directly in the command shell or indirectly through an interactive UI or use such as Angular console. I just have a new patch version available over here, so I'm going to run the npm install -g npm command. So now I have the latest version of npm. The next step over here is to create a new Angular project. Now to do that, I'll have to make use of the ng-new command. The ng-new command will be followed by the name of the project. So I'll just take a sample project over here. I'll say ng-new, and I'll just call it sample. And I'll just call it as sample project. Now, when you do this, you will encounter two questions. That is, if you would like to add Angular routing, and what type of style sheet do you prefer? So for the first question, I'll just choose yes and press Y. And for the second, I'm going to choose CSS. So I'll hit enter. However, if you are comfortable with any other style sheet, you can go ahead and select that one. Now, this is going to take a while to create a project. The ng-new command creates an initial skeleton of Angular application by default at the root level of the workspace. Not just that, it also creates end-to-end tests. When you open this application on the local host, you will see that a simple welcome page will appear, which you can modify later on to create your own application. So now our project is created. Now what I'm going to do is just get into my project. So the name of my project was Sample Project. And I'll hit enter. I want to open this project in Visual Studio Code. So I'll just type in code space dot. So now my project is opened in Visual Studio Code. As you can see over here, my project already contains a number of files that are created by Angular. The first is the end-to-end folder. The end-to-end folder contains a source of files to perform set of end-to-end tests that correspond to the root level application along with test-specific configuration files. Next up is the Node Modules folder. This provides a set of NPM packages for the entire workplace. The Source folder. Source folder contains all the root level application source files that are required for your application development. The Edit Config folder. The Edit Config folder specifies the configuration for the code editors. Git Ignore. Git Ignore specifies the intentionally untracked files that should be ignored by Git. The Angular.json folder. All the CLI configuration defaults for all projects in the workspace, including configuration options for build, serve, and test tools that the CLI uses, such as Pvt.Ltd, Karma, and Protractor. Next up is the Browsers List folder. This folder configures sharing of target browsers and Node.js versions among various front-end tools. Karma.conf.js. This consists of application-specific Karma configuration. Karma is actually a test runner for JavaScript applications. Package.lock.json. Package.lock.json provides version information for all packages installed into Node modules by the NPM client. In case you make use of Yarn client, this file will be named as yarn.lock instead. The package.json file. This file configures NPM package dependencies that are available to all the projects in the workspace. The README file. The README file contains introductory documentation for the root app. tsconfig app.json. This consists of all the application-specific TypeScript configurations, including TypeScript and Angular template compiler options. tsconfig.json. This consists of default TypeScript configuration for projects in the workspace. tsconfig spec.json file. It consists of TypeScript configuration for all the application tests. tslint.json. This is an application-specific tslint configuration. So now let me just open the source folder and show you all what's present within this. The first folder that you see over here is the app folder. This folder contains all the component files in which your application logic and data are defined. Next up is the assets folder. Assets contain image and other asset files that are to be copied when you build your applications. Environments. It contains build configuration options for particular target environments. By default, there is an unnamed standard development environment and a production environment. You can define additional target environment configurations if required. favicon.ico. It is nothing but an icon to use for this application in the bookmark bar. The index.html file. The main HTML page that is served when someone visits your site. The CLI automatically adds all JavaScript and CSS files when building your application. So you typically don't need to add any script or link tags. Next up is the main.ts file. The main.ts file is the entry point for your application. It compiles the application with JIT compiler or the just-in-time compiler and bootstraps the application root module. The application's root module is nothing but the app module, which I'll be showing you guys shortly. And you can also make use of the AOT compiler without changing any code by appending the --AOT flag. Now this --AOT flag should be attached to the build and the serve commands in the CLI. Polyfills.ts. This file provides scripts for the browser support. Styles.css. Lists all the CSS files that supply styles for this project. Tests.ts file. This is nothing but the entry point for all your unit tests with some Angular specific configuration. Typically, you don't need to edit any of the code that is present within these test files. So now let me open the folder that we are going to be modifying in order to create our application. That is nothing but the app folder. The app folder also consists of a number of files within itself. The app.component.ts file defines the logic for the application's root component or the app component. The view that is associated with this component becomes the root of the view hierarchy. The app.component.html file. It defines HTML template associated with the root app component. App.component.css file. This defines the base CSS style sheet for root app component. The app.module.ts file. This is a very important file and it defines the root module named the app module. The app module tells Angular how to assemble this application. It initially declares only the app component. However, as you proceed, when you add on more components, you'll have to specify them over here. So as you can see over here, it consists of the app component. Now when I create more components for this project, all I have to do is come and import it over here. So now that you're aware of all these files, let's move on and create a simple project in Angular. Any website generally consists of HTML, CSS, and JavaScript. HTML basically deals with the content definition, whereas CSS provides the layout. JavaScript actually helps you make dynamic and responsive web applications. So in case you do not have an idea about these, go ahead and check out Edureka's tutorials on the same. So now let's move on and write a simple Hello World program in Angular. So I've created a sample project. Now what I'm going to do is run this project. To run this project, I'll get back to the command prompt. And over here, I'll just type in ngserve. Port 4200 seems to be in use. So in case you guys encounter the same problem, all you have to do is type in netstat followed by -a, -o, and -n. Now this is going to return all the processes that are running on my PC. So what I'm going to do is just find port 4200. So I'll just type in 4200 and I'll find it. So as you can see over here, the process ID that is making use of this port is 3680. Now what I'm going to do is kill this process. To kill this process, all I have to do is come down. So I'll just remember that process ID, it's 3680. And over here, I'll type in task kill /F /PID. That's a slash, not a question mark, sorry. Followed by the process ID. It was 3680. So I'll just type in 3680 and I'll hit enter. So now the process having the process ID 3680 has been terminated. Now when I run the ngserve command again, I'll not encounter the same problem. So as you can see, my project has compiled successfully. Now what I'm going to do is go to my browser and over here, I'll just type in localhost 4200. So as you can see, our sample project app is running. This is a welcome page that is created by Angular. Now to build your projects, all you have to do is go and modify this. So I'll just get back to my project. So what I'm going to do is just open this app component.html file. I'll delete everything present over here except the router outlet. And over here, I'll just give a h1 tag. And I'll just type in hello world. I'll save this. I'll get back to my project and I'll reload this page. So as you can see over here, instead of seeing that welcome screen, all I'm seeing over here is hello world, which I modified in my project. So that was just very basic. We'll get into more details of that later on, but for now, let me tell you guys how this Angular application actually is working. The execution of an Angular application starts from the angular.json file. This file, as already discussed earlier, is used to define all the standards and paths for your Angular project. Also, angular.json file specifies which main.ts and index.html file has to be executed. So as you can see on the screen, I have both the index.html and the main.ts file present in the angular.json file. Now once this main.ts file is detected, it is compiled as it contains the code that is required to bootstrap or start off the Angular application. From this main.ts file, Angular moves to the app module. So this app module is present in the app module.ts file. So once the main.ts file is executed, it moves on towards the app module.ts file. The app module.ts file consists of all the components that are required by an Angular application. These are the components that Angular needs to know in order to run the application. So in case you create any component, it has to be declared within the declarations array present in the ng module decorator. Angular will check for this bootstrap array and then it moves on towards the app component. So the app component is present in the app component.ts file. The app component.ts file specifies the selectors, the template URLs, as well as the style URLs. All the components that are present in an Angular application are related to this root component. The app root selector is present in the index.html file. So to summarize it, I can say that the execution begins from main.ts and then it's passed on to the app module.ts file, following which the app component.ts file is executed. So like I've already mentioned before, Angular is built on TypeScript. Before moving on further in this session, I would like you guys to get familiar with TypeScript. In case you're already familiar with TypeScript, you can skip this part and move on towards the next part. Under this section, I'm going to show you guys how to install TypeScript 3.4 and then the basic types that are available in TypeScript, variables, type assertions, functions, classes, and interfaces. So to begin with, let's move on and see how you can install TypeScript on your systems. To install TypeScript, just open up your command prompt. So TypeScript is a programming language that was developed by Microsoft and it is basically a superset of JavaScript. With TypeScript, Angular projects can be created using object-oriented programming model. The TypeScript programming language is designed for development of large applications. However, it needs to be transcompiled to JavaScript as the browsers understand JavaScript only. This process of converting TypeScript into JavaScript is called as transpilation. While using TypeScript, you can make use of any of the JavaScript libraries. Also, any code you write in JavaScript will be valid in TypeScript as you can convert JavaScript code into TypeScript by simply changing the extension from .js to .ts. Also, TypeScript is not platform specific. It can be used on any browser, device, or operating system. So what is the difference between TypeScript and JavaScript? TypeScript is an object-oriented programming language, whereas JavaScript is just a scripting language. TypeScript can support static features, modules, interfaces, etc. But JavaScript, on the other hand, has no support for any of these. So to install TypeScript on your systems, all you have to do is open up the command prompt and then type in the command npm install -g TypeScript. And then you hit enter. So as you can see, TypeScript has been installed on my system. Next up, you're going to check for the version of TypeScript. To do that, just type in tsc --version and hit enter. Okay, I just made a spelling mistake over here. It's a version. So as you can see over here, the version of TypeScript that has been installed is 3.7.5. Now, to write some TypeScript code, you'll have to open up a file in Visual Studio. To do that, what I'm going to do is just type in code, followed by the name of my file. So I'll just say example11. Do not forget to add in the extension that is .ts. So as you can see on the screen, a new file has been opened wherein I can write my TypeScript code. So what I'm going to do over here is simply write one function that is going to return something to the console. So for that, I'll just type in function, which is a keyword, and then this will be a log function, and I'll just pass a parameter, say a. Within this function, I'll have a simple console.log statement, which is going to log something to my console. Next, I'm going to define a, so I'll just say variable a, and I'll just say hello world. Once this is done, I'll have to call the log function. So I'll just say log of a. I'll save this and I'll get back to my command prompt. Now, to convert this into JavaScript, you'll have to call the TypeScript compiler using the tsc filename.ts command. So here, the file name is example11. So I'll just type in tsc example11.ts. So now the file has been converted, or the file has been transpiled. So basically, when you do this, the TypeScript code will be converted to JavaScript, but while using Angular, you will not have to do this manually. The Angular CLI will automatically call the TypeScript compiler and perform transpilation when you use the ngserve command. So now if you want to execute this file, you'll have to type in node followed by the file name.js. So I'll just type in example11.js. So as you can see over here, the transpiled JavaScript has returned the output. Now in case you want to view what is present in that example.11.js file, all you have to do is just type in code example11.js. Okay, so as you can see, here is the transpiled code. The code that we have written is in TypeScript, but the code that has been transpiled to JavaScript is present in example11.js file. So I hope you guys are clear with this. In case you have any problems with the functions or the syntax, do not worry because I'll be covering each of these later on in the session. So the first thing that I'm going to be discussing over here is the basic types that are present in TypeScript. TypeScript supports almost the same data types that are present in JavaScript. These can be Boolean, numbers, strings, arrays, tuples, enum, any, void, null and undefined, never, object, and type assertions. Now, in case you're coming from JavaScript background, you guys will be very much familiar with the var keyword. But please make a note that in TypeScript, it is better to make use of the let keyword rather than the var keyword. The let keyword was included in JavaScript in ECMAScript 2015 and is considered as a standard as let is much safer compared to var. So now let's move on and take a look at each of these. So the first basic type that I'm going to be discussing over here is the Boolean data type. As many of us know, Boolean data type refers to true or false values. In TypeScript, it is preceded by a Boolean keyword. So before writing down the Boolean type, what I'm going to do is show you how to declare the types in TypeScript. So the first method is to make use of the var keyword followed by the identifier and then a colon symbol, the type of variable followed by an equal to sign, and then comes the value. So this is the first method. The second one is much similar, but you can omit the value present over here. So I'll just copy this, paste it over here, followed by a semicolon. The third way is to simply specify the value without specifying the type. So I'll just copy that. And instead of type, I'm going to have the value. And instead of the colon symbol, will be an equal to symbol. The fourth method is declaring neither the value nor the type. In this case, the data type of that variable becomes any, which means you can initialize any type of value to that variable. So I can just have a variable followed by the identifier and then a semicolon. So these are the four methods in which you can declare variables in TypeScript. So before this, we were actually talking about Boolean. So in case I want to create a variable holding Boolean values, all I have to do is type in let. I'll call the variable as b. I'll specify the type to be Boolean. And I'll give the value as false. So as you can see over here, Visual Studio will also give me details about what this actually is. So when I hover over b, it says that b is a Boolean type variable. So in case I want to print out the value of b, all I'm going to do is type in console.log b. I'll just save this. I'll get back to my command prompt. And the first thing that I'll have to do is colon tsc exm.ts. Sorry, I just made a mistake in the name of the file. It's exm2. Okay, so now my file is transpiled. Now to execute this file, all I'm going to do is just type in node, file name that is exm2.js. Okay, so as you can see, the value is false. The next basic type that's present in TypeScript is numbers. So in TypeScript, numbers are nothing but floating point values, and TypeScript supports all types of numbers such as octal, binary, hexadecimal, etc. To declare any of these, you can make use of the number keyword. So in case I just change the value from Boolean to number, and this will not be false, this will be some value, say 10. And I'll just change the name of the variable, I'll say call it C. And then instead of logging B, I'll log C. Okay, so now let's transpile our file. And then I'll type in node exm2.js. Okay, so as you can see, the value of C is 10. In case you want to specify hexadecimal, octal, or binary values, you can do it in a similar manner. So let me just take an example of a hexadecimal value. So I'll just type in let d, which is a number, equals 0, 0, 1, 2, 3. So this is an example of an octal value. The small o that you see over here specifies that this is an octal value. Similarly, if you have to specify binary or hexadecimal values, all you have to do is change this by b or x. So now let's move on towards the next type, which is strings. Strings are used to work with textual data. In TypeScript, you must use string keyword to specify them. Say for example, I have a variable, say name. So I'll type name, colon, string. I'll just change the variable name since I've already declared this before. So I'll just call it as first name rather. This is going to be a string, and I'll just specify the name as Edureka. Okay, so this is how you specify strings. Now in case you want to execute this, all you have to do is get back to your command prompt, transpile your file, and then make use of the node command followed by the name of the file .js to execute this. So now moving on towards the next basic type, which is arrays. TypeScript supports arrays just like JavaScript. You can declare them in two ways. The first is to use the type of the element followed by square brackets or an array, or specify them within angular brackets. Okay, so I'll just clear this from here. And I'll take two new variables. I'll say let AA be an array of string type. So string followed by square brackets. Now for the values, I'll just specify TypeScript and JavaScript. I'll just say TS followed by JS. Okay, so this was the first method. The second method was making use of the angular brackets. So I'll just type in let AB, which is a new variable, followed by the array keyword, and then I'll open up the angular brackets and specify the type. And then you can pass in the values. You can specify any values of your choice. So this is how you declare arrays in TypeScript. So I hope you guys are clear with this. Next up are tuples. Tuples are types that can also be used in TypeScript in case you have to define arrays with fixed number of elements whose data types are known, but they can be different. So this means I can have any variable. For example, let AC be a tuple of numbers and strings. So I'll just say number, the first element, and string as the second element. So here I know the type of data that this tuple is going to hold, but it's not going to change over time. Okay, so the next type that I'm going to be discussing over here is enum. Enum in TypeScript allows you to define a set of named constants. Okay, so if you guys are wondering what are constants, constants are variables whose values cannot be changed. Say for example, I just type in const, which stands for constant. I'll declare a variable AD, and I'll specify its value to be 10. So what happens when I do this? When you make use of the const keyword, the value of this variable, which is AD, will not be changed over time. So if you guys are wondering when you should actually use this, you must make use of const for all those variables whose value you wish to preserve and not for the others. The idea is that if a variable didn't need to be modified, someone else working on it should not do it. By using the const keyword, the code becomes foreseeable and helps in reasoning out the flow of data. So now the enum type. Enum in TypeScript allows you to define a set of named constants. Using these enums, you can make document intent easily or even create a set of different cases. In TypeScript, you can use both numeric enums and string-based enums. Enums are defined using the enum keyword. So let me take an example of a numeric enum. So what I'm going to do is just type in enum, which is the keyword, followed by fruits. And then I'll just call this enum as fruit. Now what I'm going to do is specify some values within this. So the first value is going to be apple, and I'll equate apple to 1. Now I'll discuss why I'm doing this later on. Now let me take another fruit. I'll say banana and mango, and finally an orange. Okay, so this is how you declare an enum. The numeric enum that you see over here has apple initialized to 1. The other members are auto-incremented, having the values 2, 3, and 4. In other words, fruit.apple has the value 1, banana has 2, mango has 3, and orange has 4. However, it is not necessary that you have to specify any value to this. In case I just remove this value, then apple will be initiated to value 0, banana would be 1, mango would be 2, and orange would be 3 respectively. This auto-incrementing behavior comes in handy when we do not care about the member values but do care that each member has a distinct value in that enum. In case I want to return the value of any of these, what I'm going to do is just type in console.log. And over here, okay, before this, I'll just take a new variable, or I'll just call it as fruit name. This is going to be a string, and then I'll just call fruit of 2. And then I'll log the fruit name. Let me just